Welcome to Series 2026. Hello, my dear friends. And today we are studying mathematics. So, those who are new to this series, in the introductory video, we discussed that in mathematics and science, there are very troublesome topics. Yes. I'm living in a village in the mountains. This is the cow that is mowing, so please ignore and concentrate on my voice. Um, I was saying yes. So, but there are some topics in mathematics and science which are, we do not understand what is happening in those chapters. So I'm decoding everything in the most easiest format you want. So in the comment, you can send me if there's anything that you need to be decoded. I made some small playlists for grade wise. These are from 9th to 12th grade, mathematics and science only. So I made a playlist. Whatever you are troublesome with, just click on that. And while in that files, you are gonna see the most frequently asked questions because I know your periodic exams will be coming. So yeah. So this for today, we are gonna do grade 10th, chapter number 1, real numbers, all the troublesome questions, number 1. Number 2, all the frequently asked questions that if I do just these questions, the chapter will be completed, like 80% of the chapter. How do I know? You will ask. I'm teaching from the past 14 years, not selling you anything. These are just the videos to help you out because I open Instagram, I open YouTube. Everywhere people are selling us something, and I do not want this to happen. So, this is just an act of positivity because I know that not all of you might be taking classes and not all of you might be going to like really good teachers in school. So, this is just an act to help you guys out. And I don't know, just maybe if I get like a one person understanding these questions better, then I think my effort would be worth it. So yeah, I have my NCRT page or PDF opened, but if you guys have a book with you, please do open that also because I'm gonna say page number and example number. Due to copyright issue, I cannot share my own PDF with you, the NCRT PDF, correct? So let's get to it. When you open real numbers, you will see on page number 2 the one example, page number 4, sorry, one example that is known as fundamental theorem of arithmetic. So, what is the meaning of this? And you have seen this beautiful thing written everywhere. It sounds so complicated, but it's like so beautiful. You're gonna say. So, first, write in your notebook if you have it. First, you're gonna write fundamental theorem of arithmetic. What is the meaning of it? You're gonna wonder. That's good. The questions you have, never say, oh, it's fine, do that. Always figure out why I'm getting this question and understand the basic crux of it. Because if you're asking question, meaning you're understanding the topics well. Anyway, you see a wall behind me. This wall, if I dissect it or if I break it using some hammer or so, this wall, I'm going to see some bricks from which this wall is being made. Correct? Similarly, take a number, huge number, like 10. We are studying grade 10, so I'm going to use 10. Let's say this 10 is a wall. If I break it, how do I break 10? I break using prime factorization, okay, or just factorization. If I break it, I'm going to get 2 and 5, correct? Which are prime numbers, also known as bricks of the wall. This is me making the words, okay? This is not the official word. Bricks. 2 and 5 meaning prime numbers. Prime numbers meaning those numbers who can be divisible by themselves only, okay? Just giving you a liner about it. I know that we started this number like sixth or seventh grade or something. Might not be remembered by now. So yeah. So this is prime numbers. What is this factor fundamental theorem of arithmetic is saying? All the numbers, all the composite numbers, we can divide in prime numbers. That's it. Meaning this is a composite number and we can divide it into prime numbers. This is known as fundamental theorem of arithmetic. Two types of questions will be asked from that. Can there be a third type? No. Highly unlikely. So the two type of questions are Page number 4, example number 1. Earlier, like 2 years before, this question was being asked in 2 marks. Like they were favorite questions in board examination. Nowadays, they're asking in MCQs or, not so frequently. They can be asked, but it can be asked in 2 mark question. Give example number 1 a read. Pause the video if you want to read it and, understand it. I'm just dictating and telling you how to do it. What is the meaning of it? The typical question, but it is so easy. You're gonna say, I'm not judging. If it's not easy, you're gonna make it easy. Because I believe that if we understand something, it is easier for us. Even if the easy topic, easy and hard is just a matter of mentality. If you're understanding it, it is easy for one. If you're not understanding it, it is difficult for the other. So let's make it easy. Example number 1 says, consider the numbers 4 power n, where n is a natural number. Careful. Check whether there is any value of n for which 4 power n ends with the digit 0. First mistake that people are making, they are making the power 0, and anything power 0 is 1. Nope. The question is saying ends with the digit 0, meaning let's say this is the power n, which is ending with 0. So they want this power to be something. Okay. So they are saying check whether, like if there's any value where power is ending with 0 or not. That's what they are saying. How to do this question? First, understand the question, right? 4 power n is given, saying n can be any power where once digit, the last number has to be 0. Is there any number? Solution. If anything ends with 0, 5 has to be there. See, any number which is ending with 0. I can say 2 multiplied by 5 is 10, or 10 into 10 is 100. So everywhere you're getting 5 somewhere in prime factorization. So let's show the prime factorization of 4 power n. How to do? Like this. Ignore n for now. So when you do prime factorization, you're getting 2 into 2 power n, which you can also write as 2 power square n, or you can also write as 2 power 12. Correct? Here we are not getting 5 anywhere. So you're going to say, no, we are not getting any number which is ending with 0. This is the explanation, but we are not presenting like this. Otherwise, I'm going to get 0. How to present this question? Any question which is like this, 4 power n, 6 power n, anything. First, steps for me, but you have to write like this. If anything power n, always do factorization. Show factorization. Okay? Second, I'm going to write as per uniqueness of fundamental theorem of arithmetic guarantees. Please write the full thing, okay? I just do not want this video to be very long. That's why I'm skimming it. So, as per the uniqueness of fundamental theorem of arithmetic guarantees that there are no other prime factorization of 4 power comma n, 4 power n, meaning we are not getting 5 anywhere. Therefore, there can be no number which is ending with 4 power n. So it has to be in 3 steps for 2 mark, correct? These are the first type of questions you're going to get. Second type of questions in fundamental theorem is this formula. LCM into HCF is equals to product of 2 numbers. That is an example number 2. If you multiply any 2 numbers, it has to be equal to the multiplication of LCM and HCF. Lowest common factor, highest common factor. These questions can be fine, but problem-based questions that is asked in only one question that has been asked in assignment is 1.1 last question. You have to figure out if it is HCF or if it's LCM. So this is also the very commonly asked doubt among students at how to figure it out. Firstly, I would say 2 things. Product of 2 numbers only. We cannot say that it is applicable to 3 numbers. Let's say if we have 3 numbers, 5, 6, 7, the product of them will not be equals to LCM and HCF. First mistake we are doing it on 3 numbers, it is not applicable. It is applicable only on 2 numbers. Second mistake is how to figure out when to take LCM and when to take HCF. So if we have, write it down somewhere, okay, these numbers, these names, these keywords, if it is being used, then we are using LCM, least common factor. Least common factor is doing LCM like this. Altogether, factorization altogether. The keywords are minimum, smallest, least, together, simultaneously, repeat, interval. Write it. I will also, write here. So you can see minimum, smallest, least together, simultaneously repeat an interval. Correct? If these are the words getting used in statement, you are going to use LCM. For HCF, the keywords are maximum, highest, greatest, getting me? Because highest common factor, longest, divide exactly or equal size. So this is where we're going to use HCF method. This is all the questions you're going to get from 1.1. Okay, the weird one. Now come to exercise number 1.2, the second weirdest question. You can pause the video here just to take a look at these questions and solve right away. If you're not getting anything, comment me. These videos are just for you, not for me. I do not want you to do anything with these videos. If you are studying somewhere else, it's really good. It's fine. Because there are plenty of YouTube videos you can study mathematics. So it is completely fine. Go look at that. Or if you have a tutor, ask them these questions. If not, just comment me. I'm here for you. Second type of question that will be there for 4 mark, right? That is irrational number. And this is the most troublesome question that students are not understanding or they are just hating the chapter because of that. So my work is to make hardest topic into the easiest one. Correct? Let's do this. Always the question will be like this. Prove blah blah number is an irrational number. Okay? Only two types of questions will be there in that. Divide this in two types. If what is a rational number? Anything is an under root which is not a square root of anything. Like 25 square root. This is not a rational number because 25 square root is 5 or 100 square root is 10. These are not a rational number. Irrational number are weird sound which cannot be solved further. So these are irrational. Two types of questions will be asked. First one, they will be saying root 2 plus any number, root 2 minus any number, root 2 divided by any number. That's a separate presentation. Okay? The most 4 mark question they're asking, these are 2 mark. 4 mark question is prove root 7 is irrational number. First step, always to write root 7 is assuming root 7 as a rational number. Rational number meaning which has a numerator and denominator, a and b. And always write b is not equals to 0, otherwise it is infinity. So for example, if I'm writing 1 comma 0, then this is infinity, it cannot be solved further. So first, always assume it is a rational number, correct? Second, always square both sides. Squaring both sides. For this, I always refer R.D. Sharma because it is like really good for all our questions. But be careful because there are so many different questions I do not want you to do. It will not be asked in examination. Okay? Leave a square alone. That is our first equation. After squaring. If you want me to slow down, just let me know, okay? In next videos, I'm going to post while slowing my speed down. Third step is always assume C as an integer. Correct. So now the third step is you're going to write B is taken from above is always equals to 7C and always write C is an integer. Then squaring both sides, you're going to get B square is equals to 49 C square, which is your equation number 2. Okay. Equation 1 was this, equation 2 is this. Now write from equation 1 and 2, can I say that this is 7b square is equals to a square and this is b square is equals to 49c square, right? That a square is divisible by 7 and b square is also divisible by 7, correct? This is divisible, this is divisible. So write a square is divisible by 7, a comma b square. Both are divisible by 7, meaning we can cut them, correct? So you're going to write like this and say, therefore, A and B has a common factor. common factor 7 because both are divisible. Therefore, we can say that A and B are not co-prime numbers. Make an assumption here also. Where is it? Where you have assumed A comma B where B is not equal to 0, right? A and B are co-primes. Co-primes ka matlab, what is the meaning of co-prime numbers? Meaning prime numbers which cannot be divided further, like 1 comma upon 2, 3 comma upon 4. If I write 30 and 40, it can be divisible, which are not co-primes. So these are co-prime numbers, and since both the numbers has common factor 7, these are not co-primes. And then now write this statement. I'm not writing, okay, I'm dictating it. This contradicts the statement that A and B, A divided by B, are rational numbers. Therefore, root 7 is not a rational number, it is an irrational number. That's it. This is the line that is given on page number 8, third line. This contradiction has arisen because of our incorrect assumption that root 3 is written here. It is same for everything. Root 3, root 7, root 5, root 11 or anything is rational number. So we conclude that root 3 is irrational. First type of questions, irrational and rational. Second type of questions are here. Let's say if I'm adding anything, let's say I'm adding root 7 plus minus or any operation is done, 3. Okay? Again, same stuff, first step remains the same, that it is equals to A upon B, where B is not equals to 0 and A and B are co-prime. Okay? Co-prime numbers. Again, squaring both sides. Root 7 plus 3 whole square equals to A square plus B square. If you do this, you're gonna stuck. Why? Because see, square, how I'm supposed to square this? A plus B whole square? No, I'm not doing that. So the basic interpretation of this is just do like this. Nothing else. Do not square A upon B. What is my irrational number? Root 7. Leave it and transfer everything to the other side. You do not have to solve. Please do not solve because it will take unnecessary time. It is plus 3. I'm going to say minus 3 here. So root 7 equals to A upon B minus 3. That's it. And write in bracket. So root 7 is equals to a rational number. Why? Because it is in division, that manner. And we know that irrational numbers are not equals to rational number. Therefore, root 7 plus 3 is an irrational number. A line above that, therefore our assumption is incorrect. Root 7 plus 3 is an irrational number. That's it. These are all the questions from chapter number 1. If you have any more questions, any more doubts, send across. Your girl is sitting here.